From the surface, it looked like an environmental disaster. Heavy cranes hovered over a protected bay as massive concrete blocks were dropped straight into the ocean, vanishing into water where nothing but sand had existed before. Not a few blocks, not dozens, more than 10,000, each weighing close to a metric ton, placed deliberately on the seafloor of one of Western Australia's most protected marine zones. To anyone watching, it felt wrong. This was the kind of industrial intervention usually linked to scandals, protests, and lasting damage. But nothing about this operation was accidental. What was happening beneath the waves was a calculated attempt to solve one of the hardest problems in modern food production by turning the ocean itself into the machine. Please take a moment to subscribe and like the video. It really helps the channel. The target of this underwater build is the Greenlip abalone, a marine mollusk so valuable that top-grade wild specimens routinely sell for more than $100 per kilogram in Asian luxury markets. For decades, the global seafood industry has tried and largely failed to farm abalone at scale. On land, abalone farms rely on tanks that demand constant pumping of seawater against gravity, non-stop filtration, artificial feeding, and tight temperature control. These systems consume enormous amounts of electricity, often require antibiotics to control disease, and regularly collapse under their own operating costs. Wild fisheries, meanwhile, have been overexploited, driving stocks down and prices even higher. The contradiction was clear. Abalone thrive in the open ocean, but the moment humans tried to recreate that environment inside concrete tanks, the economics stopped working. At Flinders Bay, the engineers behind Rare Foods Australia made a radical shift in thinking. Instead of forcing the ocean into a factory, they asked what the ocean already does better than any machine. The Southern Ocean moves millions of liters of cold, oxygen-rich water every second, completely free of charge. It delivers nutrients, flushes waste, and maintains stable temperatures without a single pump or filter. The only thing missing was structure. Abalone cannot survive on bare sand. They need hard surfaces to cling to, crevices for protection, and complex water movement to feed efficiently. If nature had not placed a reef there, the solution was to build one. The result was ABITAT, a proprietary artificial reef technology engineered specifically for abalone ocean ranching. Each unit is a pyramid-shaped block made from marine-grade, pH-neutral concrete, designed to chemically behave like natural rock. The shape is not decorative. Angled faces and internal voids are engineered to control water flow, slowing currents in some zones while accelerating them in others. This creates sheltered areas where drifting algae naturally gather, while faster channels carry waste away. Each ABITAT weighs roughly 900 kilograms, heavy enough to withstand powerful ocean swells, but stable enough to rest on a sandy seabed without sinking. Between 2016 and 2018, around 10,000 of these units were placed across a 400-hectare lease inside the Ngari Capes Marine Park. Even at this scale, the structures cover less than 1.5% of the seabed, leaving the surrounding environment largely unchanged. Once the reef was finished, the heavy machinery disappeared, and the project shifted from construction to biology. Abalone do not begin life on the ocean floor. They start in land-based hatcheries, where early growth is carefully controlled to give them the best chance of surviving later on. After about 18 months, the young Greenlip abalone reach a critical size of around 40 millimeters. At this stage, they are large enough to survive predators, yet still able to adapt to the powerful movement of open water. That brief window is the moment everything hinges on. Divers return to the reef carrying thousands of these juvenile abalone and release them directly onto the ABITAT structures. By now, the concrete is no longer bare. Algae and microscopic life have coated the surfaces, turning each block into a living food source. As soon as the abalone make contact, they clamp down with their muscular foot, locking themselves into place. After that moment, human involvement nearly disappears. There are no cages, no fences, and no feeding systems. For the next 2 to 3 years, the abalone live as wild animals, shaped entirely by waves, currents, and the Southern Ocean above. This constant exposure to strong water movement is not a disadvantage. It is the defining feature of the product. In land-based tanks, water is relatively calm, and abalone expend little energy holding on, producing softer flesh with higher water content. On the Flinders Bay Reef, every wave forces the abalone to engage its main muscle simply to remain attached. That muscle is the edible part of the animal. Over thousands of hours, this constant tension increases muscle density and reduces water content, creating a firm texture almost indistinguishable from wild-caught abalone. It is, quite literally, strength training powered by ocean physics. During the growth phase, operating costs are extremely low. There is no electricity used for water circulation, no manufactured feed, and no antibiotics. The ocean handles oxygen delivery, nutrient supply, and waste removal on its own. Monitoring is limited to periodic biological checks and security patrols to prevent poaching. Growth averages around 30 millimeters per year, supported by cold, nutrient-rich waters. When the abalone reach roughly 140 millimeters in shell length, they are ready for harvest. Harvesting returns divers to the seafloor. Using surface-supplied air systems for extended bottom times, they carefully pry the abalone from the concrete, overcoming the powerful grip that has strengthened over years of exposure. The catch is immediately chilled to preserve sweetness and texture. From seabed to processing, every step is designed to protect the qualities created by years of natural stress and adaptation. The result is a product that is technically farmed, yet biologically comparable to wild harvest. Commercially, the model works. Annual harvests have reached record levels above 80 tons, with recent total sales around 88 tons across all product lines, and a long-term target of roughly 100 tons per year from the ranch itself. This represents close to 20% of the world's supply of ranch-grown Greenlip abalone. The economics are the reverse of traditional aquaculture. High upfront construction replaces decades of spending on energy, feed, and medication. While land-farmed abalone often sell for $30 to $40 per kilogram, Flinders Bay's ocean-ranched product commands prices closer to wild stock, frequently reaching $80 to $100 per kilogram. The environmental outcome has surprised even critics. What was once a flat, sandy seabed is now a complex reef system. Surveys show rock lobsters, snapper, dewfish, sponges, and other marine species colonizing the habitats, rebuilding food webs that previously did not exist in this location. Instead of harming the ecosystem, the structures have expanded habitat and biodiversity, challenging the idea that human-built infrastructure must always damage nature. The team behind Flinders Bay has also found ways to use the ocean's natural conditions twice. At around 20 meters below the surface, temperature and pressure remain stable year-round. These conditions happen to be ideal for aging wine. Sealed cages of bottled wine now rest alongside the reefs, maturing quietly underwater. After months beneath the surface, the bottles are recovered and sold as ocean-aged vintages, often at many times their original value. It is a small addition, but one that reflects the mindset behind the entire project. If nature provides the conditions, the smartest solution is to let nature do the work. As aquaculture supplies more than half of the world's seafood and demand continues to rise, Flinders Bay points toward a different future. One where infrastructure works with natural forces instead of overpowering them, where operating costs are stripped away by physics, and where materials like concrete, often seen as ecological enemies, become foundations for recovery. The project leaves behind an uncomfortable question. Should empty stretches of ocean floor remain untouched out of principle, or can intelligent engineering restore ecosystems, produce food, and do both at the same time? At Flinders Bay, that question has already been answered, quietly, beneath the waves. If you want to understand the engineering shaping our world, subscribe to Unthinkable Build. Until next time.